So in this video I'll discuss about desired reflection phase shifting impedance matching network designer. Okay, so at first let's download the file. Okay, so where we can find the, yeah, I need to download this file. Okay, run anyway. Take some time. Yeah, so here we have desired level impedance matching network. So why we are saying desired level? So you can control the reflection coefficient. In general, in perfect or conjugate impedance matching network, this rho is 0, but you can set this rho, let's say 20 dB, 30 dB, whatever you want. You can select according to that, and your transmission coefficient is basically square root of 1 minus rho square. So that depends upon the rho. And typically if you take 30 dB or it's almost 0 dB, okay, so there is no problem with that. And here you have option of symmetric and asymmetric. You can change the substrate, so by putting different value of height and your epsilon r or permittivity, you can change that according to your desired one. Okay, whatever your desired. Okay. And here it is very simple to use. At first we can choose, let's say, simple lump topology. So and then subtopology is a pi network or let's say T network, and it automatically loads some default value and you can change as per your requirement. Okay, so let's say we are doing for the lossless design, we are not doing for the lossy design. Just simply put design, done. Now you can simply do the analysis also. Let's say we have done that. So our requirement is 0.1 reflection coefficient. So we are getting 0.1 or let's say minus 20 dB at the design frequency. But I want this value just come here. Okay, so for that what I can do, I can change the value of psi. So let's say put psi equals 0, design analysis is coming closer. So I can choose, let's say, psi equals to minus 20, design analysis. It's not improving, so I need to go beyond that. This is 60, design analysis. 60 is not good. 60 is basically having a good impedance matching at around 1 point something 1.09 or something like that. So for that what I can plug in 90, design analysis. Yeah, 19 is better, and more than 19 I can plug in 120, design analysis. Okay, and if I want more than that, 120, 140, design analysis. My goal satisfied. So I can see the reflection coefficient 0.01 to let's say 3. I want to see at a minus 30 dB scale. Okay, and then again I plug in the analysis. Okay, so I can see. Okay, so I have created a 20 dB matching. Okay, and also my phase shift is requirement is 90 degrees, so I am also getting the phase shift. Yeah, I'm getting at 1 gigahertz. I'm getting a 90-degree phase shift. Okay, so if you click on perfect location, I could have get exactly 90 degree. And now if I want to see what is my delay is basically basically the group delay. So group delay is not a very constant, it's basically time varying, and my requirement is around this point, and it's almost constant, or you can say it's varying, okay, but not significantly. Okay, so now you can again see the my amplitude. Okay, so what we can do, we can create a broadband matching network. Okay, so for that, what we can do, we can select this as instead of 3 section and 90, I can plug in, let's say 270 to 70. Okay, and again just do the design analysis. I have created a 20 dB. Okay, it says quite broadband. Okay, I can change this characteristic further by tuning the psi. So let's plug in 0, design, analysis. Okay, so this is creating 1 2 3 3 null, and now I just want to decrease this. So for that, what I can do, I can change the psi to, let's say 30, designed, analysis. Yeah, I think it has been decreased a little bit, so I want to further decrease it, let's say 60 may be better. Design, analysis. Yeah, so with 60 I can basically all the deflection coefficient are below 15 dB, and it's showing a good result over the band of frequency. And I have basically created a broadband matching network, and that I've also created a desired reflection level. Okay, so you can see here, these are the component I have used, 1.49 picofarad, and these are basically automatically calculated based on the algorithm. And let's say I want to design so for a frequency dependent load. So for that, what I need to do, so instead of that, I can do a frequency dependent load. I just need to, let's say I have some file, desktop, and so it is a dipole antenna I am loading. Okay, and please note that from this version it support all kind of H1B file. Previously only touchstone 2.0 was supported, now it support all kind of touchstone file. Okay, so it automatically loaded, so I can understand my frequency range is 0.05 to 1.3, and sorry, 0.05 to 0.13. So within that I have to select my resonance frequency. The resonance frequency I'm selecting as 0.5. I can select, let's say 0.8 gigahertz or 800 megahertz. And let's do the design first, and then later on you can modify the parameters. Design, it is okay, sorry 0.08, design, and I have only one section, so make it 3 section, and instead of 90, let's say 270. Design, analysis. Yeah, so I have created a matching network. Okay, so I just need to change the bandwidth a little bit. So for that, I can start with 0, design. Okay, so here we can see a design of pi distributed 5-base matching network. So I'm doing the simulation from 0, 1 to, let's say 3 gigahertz, and I'm also changing this limit, this cutting parameter, and I can see here I can get a minus 20 dB matching, and also I can get desired phase shift. Okay, I can switch between the phase delay, okay, or group delay. Okay, So let's change that to a wider bandwidth, let's say 5 section, and this I'm making at 450. Design, I think multi-section is not, option is not there by default. There's a problem with that. 2 section design, yeah, 2 section is possible. I can do the design and let's plug in the analysis. Yeah, this is the analysis. So instead of 450 I can make yeah 150. I can change this size to, let's say 0. Okay, so I can get my desired matching, okay, with 2 section, and I can see the phase and the delay. So it is basically the group delay, and this is not reflecting the exact nature because of a sudden change. Better, I just want to see only this result. Yeah, so you can see it is almost having a flat variation. Okay, so that's it. So goodbye for now. We can discuss later in details, and the link of this software will be given in the comment section.